SIG meeting. Today we've got speakers from 3 universities, and I'm going to let them introduce themselves, although you probably know all of them already. 3 universities here to talk to us about data science degree programs, and you know, the sort of intentionally catchy title was, should we even have these data science degree programs? But what we're hoping to hear from these folks is how their institution arrived at the decision to provide or not provide data science programs to students at their institution. So I'll call out the speakers' names, and maybe you could give a brief introduction, and then we will we'll jump right into these talks. So Sarah, do you want to go ahead and introduce yourself?
Sure, happy to. So my name's Sarah Stone. I'm the Executive Director at the University of Washington eScience Institute, and I co-chair our special interest group on data science education and career paths. Yeah, and I've been part of the Moore Sloan data science environments and been active in this working group since its inception. And should I go and share the?
Let's get an introduction of the other 2 folks. And
then, sorry, I didn't know if we were moving in. I didn't know the order. Sorry.
No, that's good. Jack, do you want to go ahead? Oh, still muted. Let me. There you go.
I'm Jagadish. I'm a professor of computer science. I'm the director of the Michigan Institute for Data Science, University of Michigan. And I, as part of being director of the Michigan, so I'll be talking about 5 different programs that we have at the University of Michigan. And I'm currently in charge of one of them. I was previously the one who started in and was in charge of another of them, and before that of yet a third. So you'll get a bunch of different perspectives of me in different roles doing data science things at my university.
Great, thank you. And then Ajay.
Yeah. Hello, everyone. I'm Ajay Anand. I'm the Deputy Director for the Gergen Data Science Institute. It's at the University of Rochester here. And this is where we are hosting our master's and our undergraduate program in data science. I've been here at UFR for about 3 years. And when I came in, the program was just getting launched on the undergraduate side. And you know, be glad to share our update on where we are and what the thinking was to get to this point.
Great, thank you. So let's circle back to Sarah as our first speaker, and then we'll run through in that order again. And we can take questions in the chat, but we may save questions to the end of the entire session, so we make sure everybody gets time to talk, and then we'll field questions from everyone at the end of the 3 talks. So Sarah, do you want to go ahead? Are you able to share your screen?
I think you're muted, Sarah.
Oh, there we go. Sorry, for some reason it muted me again as soon as I shared my slides. I'll take it personally. Great, okay. So now everybody can see the slides?
Yep.
Okay.
Yeah, thank you.
Great, okay, thank you. So today I'm gonna be talking about the approach that we've taken to data science education, which is really a university-wide approach to create an integrative education program through formal data science options, which I'll go to in some detail. These options are now offered by 18 different academic departments or units at UW, I'll also briefly just take a little time to talk about our informal education programs if I have time. And just to note that, these programs have also, or were created in the context of also supporting kind of transformational individuals, both in academic tenured career paths, as well as less traditional data scientist career paths. And those career paths have been critical to the creation of this curriculum. So I won't talk those in detail, but I'd be happy to touch base with folks, on other channels about some of those career paths, both traditional and non-traditional. And I'd also like to note, so David Beck's also on this call, and so David, I encourage you, if you're able to, if you pipe in as I'm moving to slides. Dave and I both work with departments to help them instantiate these options that I'll be thinking about. So just a little background on the eScience Institute. The eScience Institute's been around for 11 years and is really focused on empowering researchers and students, as said here, in all fields to use data to answer fundamental in their research. And we think of structure our institute around supporting every aspect of the data science workflow. So we don't sort of have a sweet spot in AI or ML like many institutes that are forming. We really think about the full data science workflow. And only work sort of with big data. We also, are interested in any questions where people sort of are outgrowing their spreadsheet or dealing with complex, noisy data. And we to make ourselves a hub for data intensive discovery on our campus, and so a lot of building activities help bring together innovators, again, across all fields in the techniques, technologies, and best practices of data science. And I think that framing around serving all disciplines has really been integral to how we've structured our data science programs, because we see data science as sitting in each of the individual fields, and that all fields are now facing, data challenges and can take advantage, or should be taking advantage of the data science tools. And so in that sense, we felt it was really important to integrate data science education within the departments and to have flexibility about how that data science education looks like, or what that data science education looks like at the departmental level. Do a lot of different types of activities in eScience, structured around community building, education, and research. Obviously, I don't have the time today, and the focus today is really on education. So I'll be diving in here, looking at education and primarily the formal educational activities that we've conducted primarily over the last 6 years or so. I want to note, I think, one of the things that's allowed us to be very successful in terms of the development of this program on our campus is that the eScience Institute isn't a department. And so we can act as a player, and we have this interdisciplinary mission. And so therefore, that's allowed us to bring together departments that might not otherwise come together and talk to each other if this were, say, seen as a CS initiative or a stats initiative, or even just a methods department initiative. And I think that's been important for us in terms of what we've been able to accomplish. So I will just quickly distinguish here, as I said, so I'm going to focus on formal education pathways, but we've certainly found, and eScience supports a number of informal educational opportunities, recognizing that these can help to fill the gaps as we develop these formal data science options in the curriculum, and also for folks who those aren't accessible to, like senior faculty or postdocs or graduate students who aren't able to devote that much of their time to a formal curriculum. So in the context actually of the more slow data environments, we did an education working group, and that comprised more than 15 faculty from more than 15 different departments who came together and decided on shared goals, and as you'll see, created a framework for the development of data science on the University of Washington campus. Broadly speaking, the goals were to educate all UW students in data science, and recognizing a distinction between some students needing to learn how to use data science tools, whereas some need how to build data science tools. And those who are learning and need to build data science tools are by necessity likely going to be taking different courses at a higher level than those who are wanting to be able to use existing data science tools. The second goal was seeing, as I've mentioned already, that data science was really integrated into existing departments and units. So that students graduate with the data science that are most appropriate for their disciplinary field. And so you'll see the different options and the amount of flexibility that allows departments to choose courses that are most appropriate for their discipline within this broad framework and category of data science areas of expertise. I think this has also been important in the context that departments then own data science. Data science isn't a separate department, division, or school. The department can own that. They aren't losing students to another department on campus. That also allows the departments vote on these options, and so it gives them ownership. We've taken the full view that anybody who thinks they're doing data science is a data scientist and can be part of our community and join both the eScience Institute and in data science into their disciplinary field. And last, we structured a lot of activities around creating an interdisciplinary community of data science students. I won't focus as much on those today, but I will mention them briefly. But this is a series of regular community building activities, and these are tied into our eScience Institute community. So looking at these data science options, we were fortunate, I guess, at the University of Washington that there was a structure in place for something called a transcriptable option. I'd also think of this as a specialization. The way this works is that a student, for example, and I'm using the oceanography example as having a background in oceanography myself, but a student would get a degree in oceanography, and on their transcript it would say that they did an advanced data science option. So it's called a transcriptable option. It appears on the transcript, and that reflects training in the suite of courses that I'll go through in more detail. The way that a department instantiates an option is they work with us directly based on this framework that was created by the working group. And so they work to make sure and we verify their courses identified, follow that framework, and then the department faculty vote on the option. The graduate school reviews the option with input from any departments that are impacted by that option on campus. And then that graduate school or that department can then start offering the option. At the graduate level, this moves pretty rapidly. Graduate education, I'm sure everybody will probably be nodding their heads on this, is much less impacted and much easier to kind of make changes to than undergraduate education. At the graduate level, we've developed two options, an advanced graduate data science option and a standard option, and I'll work through those in the next couple slides. We've also developed an undergraduate option. Again, this is similar in the sense that this is a transcriptable option, it's similar in terms of the process, but there's, as I mentioned, more paperwork and there's more hurdles to go through because undergraduate curriculum tends to be much more full. And so I would say departments are more challenged fitting in additional courses, especially for departments outside methods disciplines. So for the advanced graduate data science option, as I mentioned, we did make this distinction, especially at the level between tool builders and tool users. So the advanced graduate data science option is for, or developed for tool builders. And this was the first option that we created. And this was actually done in the context of an NSF IGERT award on data science to build out this curriculum. What this looks like is that students need to take 3 out of 4 courses in the areas listed here. So statistics, ML, data management, and data visualization. The courses that are listed here are the highest level courses in these areas. And so these do require a number of prerequisites, again, these are for because these are for the tutors, they are pointing to the highest level courses. Just to quickly note, a lot of this activity came about, again, as I mentioned, from an NSF IGERT, and so there's a pool of students that were involved in that. We've also involved in several NRT training programs that with students who are taking these data science options or similar curriculum. And so they've become part of this broad suite of students that are involved in our community building activities, which include weekly lunches and an annual career fair. Steve, let me know how I'm doing on time. I have a few more slides. 2 minutes? Okay. So at the undergraduate level, so I'm kind of going in the order in which we've developed these options. So again, we start at the highest level of the graduate options and we're working our way down into the undergraduate curriculum. We've developed data science options at the undergraduate level. Again, these are similar to the PhD options in the sense that they are these transcript options recognized on the transcript. The undergraduate data science option looks like this. The required courses are shown here in programming, machine learning, something in privacy, security, ethics, and society. And then 2 out of 3 in the topics shown here in green. And then there are optional department-specific courses. And actually, I should note, again, any of these courses or any of these topical areas can be filled by department courses as well as courses offered in other departments. And we have generated a long list of courses that are available to students across departments in the data science space departments can point to. These are currently offered in 6 departments, and I will say very upfront, 5 of these 6 departments are methods departments. It's much easier at the undergraduate level for methods departments to instantiate these options because their students are often already taking courses in these spaces, and so it's not a bunch of additional courses or a bunch of additional prerequisites. That has led us to also work towards creating a number of introductory courses with no prerequisites. For students who are interested in data science, you know, in the vein that we've, I think, talked about in the Berkeley Data 8 course. So we have an introduction to data science that's offered. It rotates each quarter in which department is offering it. And that's a story in and of itself, but I won't go into that just given the short time frame. We also have a data and society course, which is focused on ethical data science. And data programming Python. All of these are offered without any prerequisites. Lastly, because we've recognized that for many departments, doing the data science option has been really challenging. We are in the process, there was a data science task force initiated by our current provost to develop a data science minor. And this is really trying to draw students non-STEM fields to create a data science pathway for those students. And so that's in progress and moving through the various levels of approval, and we hope to have that in place this coming fall. And this is just to wrap up kind of the timing on how we've been moving through these options. We've been doing this, you know, starting at this for quite some time. The only thing I haven't talked about in detail is that we do also have a professional data science master's program. I'd be happy to talk about that if that's of interest in terms of questions. And that program was similarly developed between 6 different departments on campus to create that program. And I think then hopefully I'm on time, and I will just, yep, oops, I jumped one ahead. Say thank you for giving me the opportunity to share with this community, and I really look forward to hearing what other folks are doing.
Great, thank you.
Thank you.
So if you could unshare your screen, and we'll jump over to Jag, who will share his screen. Perfect. And we'll need you to, well, I can unmute you. There you go.
All right. So we have a number of different programs at the University of Michigan. And I thought, just in terms of giving you a flavor of how we have it, talk about them in time order. So we started with a bachelor's degree in data science, unlike most other places that started with a master's degree. And we now have a variety of graduate degree options, which I'll get to. So let's begin with the bachelor's degree in data science. This is a joint degree offered between computer science and statistics. Computer science at Michigan is in the College of Engineering. Statistics is in literature science and the arts, which are the two biggest colleges. And the program was intentionally designed to be symmetric between the two departments. Students are admitted to a college, and so students admitted in engineering can take this, and students admitted to literature, science, and arts can take this. And the advising for all LSA students doing this is done through statistics, and for all engineering students doing this is through computer science. And even in terms of course requirements and so on, it's approximately equal numbers of computer science and statistics courses that are required. And then there's a whole bunch of options that students can take. The idea also was to rely on existing classes where possible. And so we got this whole degree program going with only 2 new classes and a capstone to the courses that already existed in statistics and computer science. So that was the first program that we launched, and we've had hundreds of students go through this. It's been going now for over 5 years. We have something called a certificate, which is probably similar to a transcriptable option that Sarah was talking about. And this is applicable only to graduate degree programs. And it's a certificate that comes along in addition to the degree. The only people who are allowed to opt for this are students who have been admitted to a graduate program. And so the student admissions happens through the regular channels to the regular graduate programs, master's and PhD. And students in these programs can then apply to add the certificate, and if they're admitted and then they satisfy the requirements, they can do this. The nice thing about this, the way that this works for us, is that the certificate is offered through our graduate school, and therefore the individual departments and programs really don't have a way of, or don't need to approve it. We've something of the order of 200 students who've got this certificate in the past 4 years. And our cohort in the beginning was mostly PhD students. And now it's more master's students who seem to be doing this. A wide range of primary fields. And this is open to every department on campus, pretty much. And one thing about the way our data science institute is run is that we are not an academic unit, and so we cannot offer degrees because we don't have regional approval to offer degrees. Only departments can do that. However, we do have the authority to offer certificates. And so this certificate program is run through our through our Data Science Institute. Everything else that I'm going to be talking about is run through other units. Then we have a master's in data science, and this is a joint degree equally shared between computer science, the School of Information, statistics, and biostatistics. And so there are basically four co-equal partners who manage the program and have appointed the statistics department as the administrative home. And so basically what that means is that decision-making is joint, revenues and expenses are joint, and then there is a cost transfer to the statistics department for the expenses that they have in terms of program staff and so on. The intention again here was to take mostly existing classes in these methods departments and try to create an MS program. There are approximately 3 new classes that were required well, okay, we can get in details if you have time. A key problem that we, and I suppose everybody else doing graduate degrees in data science has to address is what background do you assume students will have? And we wanted to provide paths to students who, well, at the very least, you want to be able to take students who have, say, a degree in CS, but no statistics exposure or very little statistics, or degrees in statistics and very little computer science. But then once you say that you're going to take these, then you could take other students who have neither CS nor statistics, but have quantitative skills, because your program requirements in any case are going to allow people with little statistics knowledge or little CS background to be able to succeed. And so what we've done is develop proficiency-based graduation requirements. And the expectation is that somebody who has a data science undergraduate degree may, at least in theory, be able to complete this program within a year and get the master's degree within a year. But the typical student takes 2 years. In practice, in spite of our own very large data science undergraduate program, several of whom stay on for the master's degree, we've thus far had exactly 1 student complete the master's degree in 1 year. Okay, it's typically 1.5 years to 2 years. We have a couple of other degree programs, and these are not central institution things. These are specific departments doing their own thing. So the School of Information has an online master's degree in applied data science, and this launched last fall. And this is designed MOOC style, 4-week MOOCs, 1 unit each, 34 courses, and it's a 2-year program. The Electrical and Computer Engineering degree, division is going to, beginning this fall of 2020, have a Master of Engineering degree. A Master of Engineering degree, as opposed to an MS, is a professional degree, a terminal professional degree. And I can talk more about that too if you want to. I want to get to this, this last thing, which is a brand new thing that is also launching this fall. And this is effectively something like a minor in data science for the bulk of our undergraduates. So everything that we've talked about thus far has been either a graduate degree or the data science undergraduate degree is a specialized degree for people who are going to be data scientists. It's not a general education thing. This is a thing that is specifically by our largest college, the Literature, Science and Arts College. And the idea is to get them to see some data science material, and particularly to take into account that students who choose to do social science majors are likely in many cases to be math shy, which is why they chose those disciplines. And so this is sort of gentle application forward introduction to data science. And it's a sequence of courses that I guess in the beginning is intended to be for people who will explicitly have this as an annotation on their transcript, the QMSS annotation. But I think the plan is to have students who don't want to go through all the way, maybe take one course, and then that becomes kind of the broad-based data science education course. But that isn't where we're starting. We're starting by saying, how do we do this for students who want to commit at least to a sequence of courses, work the thing for them, and then scale. I think I'll stop here, and I'm happy to expand on any of the things that I talked about.
Great, thank you. So we have some questions coming in, and we'll hold those till the end. Ajay, do you want to grab the screen? There you go.
Okay. Get full screen. Hello, everyone. Thanks for the opportunity to present our program. Actually, for the sake of this presentation, I focused on the undergraduate program. But as I mentioned in the introduction, we have a master's program that started first. And then this was our second program, the undergraduate program. So what we have at Rochester is essentially a BA/BS. So it's a Bachelor of Arts, Bachelor of Science combination. The program is hosted out of the Gergen Institute for Data Science. So while we are not a traditional academic department, the Gergen Institute, as it was formed within data to host data science initiative within the UFR, was tasked with both a research initiative and an education initiative. And so within the scope of the education initiatives, the launch of the master's and the undergraduate programs was facilitated. So at the outset, the motivation to have the BA program or the BS program was essentially, to really bring together the foundational skills in data science. So proficiency in algorithms and programming, so the CS aspect, the statistical methods, and the ability to apply these to real world problems. So the historical perspective to this is that a lot of the sort of catalyst for the formation of the Data Science Institute came about from our CS department. And so sort of the emphasis of how the data science program was put together was to a large extent motivated by computer science with contribution from statistics. As the program was pulled together, the charter was, what the curriculum would be to provide this foundational focus on the CS aspect, the statistical aspects, and then to build on that the ability for students to practice cross-training. So that's the area where sort of the domain expertise, the domain areas get kind of pulled in. And the way that has been facilitated in the curriculum or in the formation of this program is through what we are calling concentration areas or elective areas. So what these mean is essentially in the course of the curriculum, there's an opportunity for the students to about 3 or 4 courses, so a set of courses to specialize in a certain concentration area. The bulk of the curriculum is, yes, computer science, statistics, and we have now added core courses around ethics as well. That's thanks to contributions from our philosophy department in conjunction with computer science. And then multiple departments came together as the curriculum was put together to define these concentration areas. So we're calling them electives or concentration areas. And these are providing essentially the opportunity to emphasize a certain domain area for the students as they are majoring in data science. Interestingly, some of our most popular concentration areas have been from business, economics, political science. We have a couple of concentration areas in engineering as well. But what we are seeing there is the engineering curriculum, as I think previously pointed out, Sarah pointed out, the engineering curriculums are so dense that it hasn't lent itself to having a set of courses without a lineup of prereqs that can form a suitable concentration area. So essentially, the way it's kind of operationalized in the last couple of years is, we have a sort of a virtual academic structure for the program from the Gergen Institute. Most of the courses in the undergraduate program are to a large extent existing courses. They're computer science and statistics courses, and also the domain area courses. Based on how this was pulled together to a combination of existing courses, it was first launched in 2016. At that time, I believe it was one of the earliest undergraduate programs in data science. And over the years, yes, it has grown. Given the size of the University of Rochester, we have 50 undergraduate degree majors in the program right now. And that's, that in relation to the size of the University of Rochester, that's a decent footprint. And what is very interesting, as we have seen this program evolve, is, and this also speaks to the sort of the flexibility in many of the majors in other academic departments, is many of our students who are pursuing a data science undergraduate degree are actually double majors. So almost more than 50% are double majoring with another traditional domain area. So some of the top ones that form the double major are business, economics, math, applied math, and financial economics as well. So what has been some of the sort of the takeaways or sort of the outcomes? We are seeing, many of our undergraduates from the data science program, they move on to pursue graduate school. There are some of the programs listed here. The other half go take on industry positions. And specifically in the context of the undergraduate program, we are seeing sort of the evolution of this kind of job title industry to the level of like junior data scientists. So it's these students who are looking for primarily where they go into is sort of consulting positions or in a data science consulting joint role. Coming back to sort of how things evolved on campus, what we have also seen is the introduction of the data science major has in turn catalyzed has resulted in development of new courses in computational statistics. I mentioned a lot of the curriculum is taken from existing courses that were already in place in the academic programs, but what it brought about is the introduction of courses, let's say in statistics, with more of a computational thinking, or the introduction of statistics courses into the computer science program. And these courses, based on how they've been developed, have become more accessible to many other departments as well. So this is sort of a, I would say, an output from the creation of the data science program. In addition to having the data science program, though, what we have noticed is there's still an unmet need. So even by bringing together formal data science training through an undergraduate data science program, we still see, and this is in development now, we see a good opportunity to actually still bring together a set of courses in the form of minor or a cluster. So at UFR, we have this option for a cluster where the cluster is a subset of courses that go into a minor. It still allows a student to, actually every undergraduate student has to pick 2 clusters from a different domain area. So if someone is in natural sciences, they should be picking a cluster from social sciences and humanities, for example. So there's still an opportunity to bring together a set of data science courses without a significant prerequisite load, and then introduce that at a level that's compatible with some of the other majors on campus, again, at the undergraduate level. We see this as an opportunity to continue to enhance the data literacy on campus. And so in addition to having the data science major, this is an area we're starting to work on now. I focused this presentation primarily on the undergraduate program, the bachelor's program, but just to, in terms of evolution of our programs, our master's program came first, the undergraduate program was next, and we have put together now an advanced certificate program. We're just getting that launched. We'll be admitting the first set of cohort of students in fall 2020. It's designed essentially, we had quite some interest for students to pursue a part-time master's program, many of whom were employees in our medical center or on campus. And we see that advanced certificate may be a more sort of a more shorter term goal that someone with data science interests could pursue. So this is essentially directed at full-time professionals or working professionals who may not be able to commit to a master's program. So what's common, though, across all of these programs is it's been built or it's been predicated on leveraging quite some resources from existing programs or existing courses. But this is also where we are starting to see an opportunity to infuse some more applied courses or new domain area courses intersecting with data science into the program. I believe that's what I had for our program, and happy to take any questions.
Yeah, thank you. So we have a bunch of questions here in the chat, and I may just read them from here to avoid the logjam of microphones. So the first question that we had, I think, kind of goes out to everyone. Is are there ethics course requirements for? Well, this is really kind of aimed at UW, but are there ethics course requirements for the graduate transcriptable options, or any of the other graduate degrees mentioned by any of the speakers?
So I think actually I'll point to Beck on this, because this also relates to the community seminar question, which is later down in the stream, and Dave runs that seminar.
Yeah, thank you, Sarah. So with regards to the ethics requirements, because all of the graduate data science options rely on the community seminar to provide a certain amount of broad content, we incorporate on a regular basis discussions about ethics in those settings. And it has mixed reception. Remember that there are astronomers in that setting where the transcriptable option, it can sometimes be difficult for them to understand why they need to have an ethics seminar. And so it takes a fair amount of motivation on my part to say, hey, look, you might not be an astronomer all of your life. And even when in astronomy, there are discussions about ethics, like who gets priority access to telescope time and so forth. With regard to the second question, if I can just jump ahead here, Steve, which was in the community seminar, how do we make it appealing to both tool builders and tool users? And we have there's a number of different ways to do that. One of the things that has been really successful is the seminar speaker format. So it's roughly an hour-long seminar, and we have what's called a 20-20-20 format. So presenters will spend 20 minutes giving background in their area, whether they're a computer scientist or an oceanographer or a chemical engineer, and then 20 minutes of problem statement. So,
David, we're losing you. I think we may have lost Dave. Sarah, do you want to jump in, or should we see if anybody else wants to jump in on the ethics question?
It's fine to just to move on. I think he was just gonna, the 20-20-20 is, the methods focused and then coming together on potential challenges with that methods and applications across other fields, and time for discussion on that.
Wonderful. Any of the other speakers want to talk a little bit about the ethics requirements and motivation behind those?
We have different ethics requirements in our different programs, and specifically the Applied Data Science Masters has an explicit ethics requirement, course requirement. Our undergraduate courses have a professionalism and ethics thing, which our computer science degree does too, and we're working on how to strengthen that. It used to be, it has been a seminar type thing. We also have a seminar series that is required for both our MS and our certificate programs. And we struggle with the same issues that in terms of the diversity of speakers at the seminar series. And one of the things that we've found is that there is a huge variance in who attends. And we just sort of say that that's okay with us, and the people vote with their feet in terms of coming to lectures on topics that they think are interesting. And actually, the ethics seminars do get attended potentially more heavily than the others, because I think it's more of a cross-cutting interest.
So, Steve, just to add to that, here at Rochester, just in the last year, computer science working with philosophy has introduced an ethics cluster. So that is accessible to our undergraduate data science program. So we are promoting that as a cluster that our data science students can take. On the master side, it's somewhat a little more informal. It's mainly through seminars and seminar series. So we're taking a look at that to make it, maybe make it a little more formal.
Great. So we just have a couple of minutes left, and we have a whole pile of questions here. So I'm not sure we're going to be able to get really to any more of them. Maybe I can find one real quick that looks short.
The last one is really short.
Yeah. Well, why don't you go with that one then?
So Michaela asked a question here. Is the Gergen Institute able to offer the degrees? The answer is yes. So we are the host for all the data science degrees on campus, even though we are an institute. So the university structure allows us to do that.
And with respect to the degree granting question for Michigan, on the certificate, all our graduate degrees are given by our graduate college, not by the disciplinary colleges. And we have authority from the graduate college to issue the certificates for the certificate program. We don't have the authority to issue degrees.
Great. So it looks like there's a call here for maybe folks to stay a little bit longer if they can. We've got about 3 minutes left in the hour. So I'm happy to leave this discussion open. We can keep chatting after 11 o'clock Pacific. But I don't know if all of our speakers can stay, but those of you who want to stick around, we could do that and just kind of have a free-form discussion for a little while. For those of you who can't, I'll send out a recording here in a little bit so that you can take a look at any discussion that spills over into the hour. But I do want to thank you all for coming today, and thank you to our three speakers. It's been really great to hear your programs, and I look forward to seeing you all at our next SIG call. For those who are going to stick around, let me just run through some more of these questions. How do you adapt proficiency requirements for students from non-CS and non-stats backgrounds? I think that's directed to JAG, but it could go to everyone.
Michigan. So basically, the problem that we have, let's talk about CS, since the attendees, I think, are more CS heavy. As you know, CS programs have a long chain. You've got to do your discrete math, and you've got to do your interactive programming and instructions and algorithms. You've got to get through those classes before you can do any serious CS. And if somebody doesn't have a CS background, they're in the master's program, you've got to get them those skills if they're going to make use of the rich set of coursework that we have in the CS field. Otherwise, one is designing a whole bunch of special purpose classes for them. And so what we've basically got is a graduate version of CS 123, with graduate course numbering, so that it counts for credit. And it's spaced a little bit differently, and the primary audience are data science students. This is something that, because of enrollment pressures in computer science, we have been careful not to open to everybody. But basically, we've got the courses in place and the mechanisms in place to have essentially CS for all at the graduate level, following a relatively traditional pattern, should we wish to do that. In statistics, they've actually had this kind of thing already, so they didn't even need to build that infrastructure for the master's program, because there are a lot of people in a lot of fields who come in as grad students, and then they realize they've got to do some t-tests, and they don't know the first thing about what that means. And so there's a lot of introductory statistics courses that grad students can take to come up to speed and fill in what they don't know. And so it was just a question of creating the right pathways, and that works fine. And so these are courses that students who have the skills can skip, and that's why the length of program varies depending on the degree of preparation.
Anybody else want to touch on that? No? Okay. There was a question here I did want to touch on, which is whether the folks running these programs are hearing feedback from industry or kind of postgraduate hiring, and what those potential employers are saying about the programs and what kind of feedback you're getting.
I can say a little bit about that. I think, we're all kind of early on for sort of knowing having a big sample size of the students moving out and being able to track where they're going, although we're making efforts to do that. I would say one thing about having students in data science options in departments is the tracking challenging, because different departments do tracking in different ways. And so I have to reach out to 20 different departments to figure out what's going on with those students and where they are in advancing. And so anyway, we're still kind of tackling that logistical hurdle. But I would say, we've definitely heard that having, again, especially for students who are coming from non, traditional data science disciplines, that having data science option on their transcripts helps them sort of give them street cred if they're going from, say, being a biologist and trying to, you know, or having a biology degree and trying to get into a data science position, that, you know, that allows them to be seen as having that skill set. In terms of which courses are most important, I guess this is probably across the board. What I'm hearing is that having the machine learning, you know, courses in machine learning are what industry is really looking for right now, because they're trying to figure out if they aren't already solidly in that space, how to get into that space. And so they're looking for with those skills in particular.
Jay, go ahead.
Yeah, yeah, I agree with Sarah. So what we are seeing is, again, we have a small sample size. As I mentioned in the slide, close to 50% or higher of our students from data science are pursuing a graduate degree. And what we are also hearing is exactly what kind of data science role an undergraduate is able to fit into. So, you know, this title of junior data scientist, it seems to have come about from this undergraduate, you know, as they go down the chain of what the data scientist job classification looks like. It seems to appeal directly to the undergraduates. And so what benefited some of our students is this double major. So, you know, having a domain expert, that's a call from a different meeting. The combination of the domain area, so many of going into business or economics are going to a consultancy and bringing that data science skill set with them. But again, a smaller sample size than I would like at this moment.
And Jag, what are you hearing on this front?
Yeah, I don't think I have that much to add. I think that for the traditional degree programs, both our bachelor's and our master's degree programs, my sense is that they're very strongly rooted in CS and in statistics, the way that we do it. And a larger fraction of the students are more CS oriented, and so they're basically part of the CS job market, which is very robust. The statistics job market is pretty robust too, and I think that some of the data science students go there and actually end up doing very well, and that's been the traditional path. The more the certificate program, it really depends on the home degree, and the applied data science program is we don't yet have any grads.
Great, thank you. So people are dropping like flies, so maybe it's a good time to wrap things up. Thank you all again for coming today, and to the speakers for taking some time out. Expect to see a link to the recording from me later on, and to a feedback survey, and thanks again.
Great, thank you, Steve.
Thank you, Steve.
Thank you, everybody.
Yeah.